Hello everyone, myself Dr. Kosintas and I will be teaching you the paper Elements of Modern Physics, which have 4 credit, 3 for theory and 1 for practical. So before going to the details, you should learn about the course learning outcome. So after completion of this course, you will understand and you will be able to apply modern physics, modern development of physics, starting from the Planck's law, who is the father of our quantum mechanics, and its development of the idea of probability interpretation and the formulation of Schrodinger equations. You will be also get the preliminary idea of structure of nucleus as well as laser. So in this paper we have 6 modules. First one all about the introduction of quantum mechanics or the history of the quantum mechanics. Second will be the uncertainty and the wave particle duality. Third one is Schrodinger equations. Fourth one is one-dimensional box and the step potential barrier. Fifth one is structure of the atomic nucleus. Sixth one is laser. And here are the list of practicals you have to finish within this semester. There are 5 numbers of practical you have to finish. So you will get the list, you can study and you have to make yourself ready for the practical. So in the module 1 we have 9 subtopics, and today we are going to discuss the first subtopic, which is the origin of quantum theory of light and the Planck's hypothesis. After that we will go to the Planck's law of black body radiation, how we can derive the black body radiation formula. Then photoelectric effect and the Compton effect, de Broglie's wave, the matter wave, Davidson-German experiment to prove de Broglie's wave description of the particle by wave package, group velocity and the phase velocity of the de Broglie's waves. After that we have to study the two-slit experiment with electrons, just like Young-Double slit experiment, wave amplitude and the wave functions. So we will start with the origin of quantum mechanics from the quantum theory of light and how Planck hypothesized that theory. So in the 1900s, Max Planck actually desperately he used the quantization of energy to explain the black body radiation, because Rayleigh, Jeans and Wien already tried to explain the black body radiation spectrum, which was observed from the experiment, but they could not succeed. So basically, what is a black body? Black body is nothing but any object which absorbs or emits all the wavelengths of electromagnetic spectrum. So a perfect black body absorbs all the wavelengths, and as well as when it gets energy, it starts to radiate. As we have experienced that if we hit an iron rod or iron piece, then it starts to glow. Initially red, then orange, then yellow, and finally white glow we have observed. So here are the spectrums of, suppose, the iron for different temperatures. So in the x-axis we have wavelength, and the y-axis we have the intensity of the radiation emitted from the material. So as the temperature increases, the peak sharpens and it deviates towards the short wavelength. And all these are the experimental data, and the religions try to fit their model with this experimental method, they could not, because they tried with the classical theory of radiation. There are certain drawbacks in the in the classical mechanics. So, other those, the classical mechanics do not explain the variation of the specific heat of solids, which was later uh, explained by quantum mechanics. Classical mechanics could not explain the spectrum, observed spectrum of the black body radiation, which was done by Planck himself. Classical mechanics could not explain the stability of atoms, so that was explained by Niels Bohr. Classical mechanics could not explain the origin of spectral line, so that was also done by Niels Bohr and other scientists who did the spectroscopic analysis of the hydrogen spectrum and all other different elements. Along with that, along with this, there are several unexplained phenomena as there, but later the quantum mechanics would successfully explain all those phenomena like photoelectric effect, compound effect, then pair production, etc. So, I have already said that Planck desperately tried to explain the black body radiation spectrum. He used the corpuscular theory of the particle theory of light. It was already coined by Newton, but he could not successfully explain at that time. But Planck took the same idea and he hypothesized 3 points, and then he explained, or he successfully explained, the black body radiation spectrum. He initially thought that the atoms of the black body are nothing but a simple harmonic oscillator, and they can vibrate with all possible frequencies. Second point is the simple harmonic oscillators cannot have any amount of energy, but have to have discrete amount of energy which is equal to the NH. Well, n is an integer, h is the Planck constant, nu is the energy absorbed or radiated by the harmonic oscillators. Third point is the oscillator does not radiate or absorb energy continuously. The oscillator can exchange energy with the surrounding with discrete value, as we have already known, the h nu, twice h nu, 3 h nu, etc. From those hypotheses, Planck actually calculated the average energy of the oscillators, and which is equal to h nu by exponential h nu by kt minus 1. Here h is the Planck constant, u is the frequency of the radiation, k is the Boltzmann constant, and T is the absolute temperature of the black body, at which temperature we have measured the average energy. So in the next class we will discuss how to derive the black body radiation using the Planck's hypothesis. So we will use the quantum mechanical behavior, not the classical idea, and we will see that the spectrum, the theoretical spectrum we got from the Planck equation, which match with the experimental observation, and that is the beauty of Planck's equation. So for you, we have a homework. So today you go and study the radiation equations and points equation of blackbody radiation. So when you study these two equations, it will clear how or at which point they went wrong and they could not explain the blackbody radiation. For that reference book, you can follow the three different books I have given here. So this is for today's class. Thank you for your kind attention.